NCERT Class 11, Chapter 10, Mechanical Properties of Fluids, question number 10.4. We have been given 5 points to explain. Now, first part, that is A. To keep a paper horizontal, you should blow over and not under it. Now, we can use Bernoulli's equation to explain this. That let us suppose this is the piece of paper and we blow air above it, then you can see by Bernoulli equation I can say P plus half rho V square plus rho G H is constant. But in case since the paper is thin, this term can be ignored, and just I can say P plus half rho V square is constant. Now if you talk about 2 points above and below, this is point A and this is point B, then I can say at point A the speed is high in comparison to the speed at B, and since the sum of pressure and half rho V square should be constant, then obviously because speed of at A is more than speed at B, thereby the pressure at A should be less than pressure at B, and thereby the paper should experience a net upward force. Okay, now B, when we try to close a water tap with 2 fingers, fast jet of water gush through the openings between the 2 fingers. Then we can say that let us say that fluid which is liquid coming out from the tap has speed v1 and the cross section area was a1, and we know by the equation of continuity a1 v1 should be equal to a2 v2. Now since I am decreasing the cross sectional area by putting the fingers, then thereby we can say the speed is going to increase. Now C, it says the size of the needle of a syringe controls flow rate better than the thumb pressure exerted by the doctor while administering the injection. Now you see this is a syringe and this is the end of the syringe from which the fluids comes out, and this is of much lesser cross section area. Let us say this is area A2 and this is A1, then A1 is much more than A2, and this is the point at which we are going to exert the force. So let us suppose the pressure provided over here is PT and the surrounding pressure is a constant, that is P0. Then one thing I can say is A1 V1 is equal to A2 V2. Now since A1 is much more than A2, I can say that V2 will be much more than V1, and then I can say that if I apply Bernoulli equation at this and this point, I can say that Pt plus half rho V1 square is equal to P0 plus half rho V2 square. Then you can see that since there is a square term over here and V2 is much more than V1 because of this arrangement of cross-sectional areas, the effect of the cross-section areas is much more important and significant in comparison to the effect of this pressure Pt. Now next, that is D. The fluid flowing out of a small hole in a vessel results in a backward thrust force on the vessel. So now I can say that for example this is a container having a liquid filled and we provide an orifice over here, then this orifice is going to come out with a relative velocity, let us suppose v, and since the mass is getting detached from the container with relative velocity, it is going to be providing a thrust force and because it itself is going to experience a thrust force towards right, it is going to apply a thrust force on the container towards left, and that thrust force can be given by uh, V relative into dm by dt. That is, V relative is p, and rate of mass flow can be written as density into cross section area into speed, that is rho a into v square. Now last is, a spinning cricket ball in air does not follow a parabolic trajectory. The reason is Magnus effect. That is, for example, this is the ball and we have thrown the ball, let us suppose, towards left with speed v, and there is a spin, and the angular velocity of the spin is omega, and the radius is, let us suppose, r. Then if I take 2 points over here and here, then you see that the speed of the molecules above will be towards, relative to the ball, will be towards right, let us call v1, and that is going to be v plus omega r. And for the point below, the speed of the air relative to the point will be v2, and that will be v minus omega into r. Now again I can say that since let us call this point is 2 and this point is 1, this point is 1 and this point is 2, I can say key speed v1 is more than v2, then by Bernoulli equation p1 will be less than p2, and because of this higher pressure at the bottom point, the ball is going to experience a net force in upward direction other than that groundward downward gravitational force, and because of that the path will be not parabolic.